Hello, everyone. Welcome to the PTP 550 features and roadmap update. We are just going to start in a couple of minutes. So please hang tight. Hello, everyone. Welcome to the PTP 550 session for new features and roadmap. We'll be starting in maybe a minute or so, waiting for more people to join in. So please hang tight. Okay, I think we can get started. Welcome, everyone, once again. My name is Sagar Deshpande. I'm the product manager for the PTP 550. Today we'll be going over the following. Just kind of spend a few minutes talking about the backhaul evolution and how it's been so far. Next, we're going to talk about the sub-6 portfolio that Cambium has. Next, we're going to focus on why PTP 550. Next, after that, we're going to spend a few minutes explaining or understanding how channel bonding works and why this is so powerful. After that, we're going to spend a few minutes talking about roadmap and feature sets that come along with the 550, the next near future. And after that, we have a case study and a reference material, followed by the conclusion. All right. So for the backhaul evolution, so if you see the data over the past 2 years and then projected out in the next 3 or 4 years, you see a steady growth of data consumptions from the end users, on average about 25% each year. If you compare this with, so what this means is each end user is trying to absorb more and more content, be it Netflix, YouTube, any other video streaming applications, even games or video games online. So the data consumption, as we predict, is going to grow at least by 25% each year, which means your backhaul needs to be strengthened as well. So what this means is you need to not only plan for your backhaul for today, you also need to think about how it's going to be in a year or 2 years from now. And typically backhaul falls under two major categories, or the one way to divide them is licensed microwave, and the second part is unlicensed microwave. Licensed microwave typically are your 6 gigahertz and above. You also have V band, E band, those kind of things. So the advantage of licensed microwave is the spectrum is yours. You apply for a license for a fees, and you lease out that spectrum for 5, 7, 10 years, depending on that. And the disadvantage for licensed microwave is typically the products are a little bit more expensive. So the trade-off is you get really good clean channels. You can send high throughput. You have wider channel size, but the downside is the equipment and the license keys cost a little bit more. The other side of the backhaul is the unlicensed microwave, which are typically cheaper compared to the licensed microwave products, and they operate mainly in the 5 gigahertz spectrum. So these are the two ways for the backhaul part of it. The third one is with respect to interference mitigation. 5 gigahertz band is getting polluted year over year, which is probably almost at the same rate as the data growth, because more and more products are being put out in the field, be it IoT, be it sensors, be it industrial IoT, or any other Wi-Fi backhauls, Wi-Fi hotspots, or anything like that. So all of those, any product in the 5 gigahertz band is causing a direct interference with the radio, depending on where it is. So these are the three main key points to remember when focusing on the evolution of backhaul. So we want to focus a bit on the 550 because it's a reliable and affordable product. especially being an unlicensed product. It has a gigabit solution which addresses the demand for the growing data rate, and it has the capability of channel interference or mitigating interference from different channels, and the way it handles it is different. So we feel the 550 is a really good solution for long-term backhaul solution for the next generation of products, which focuses on gigabit solution and channel interference. Just to kind of step back and give you an overall portfolio of Cambium, this is just a quick synopsis. So we have the 4300 on the left, which does 600 Mbps, and it has 20, 40, 80 megahertz of channel. We have the 450i, which does 300 plus Mbps. It follows the ARQ protocol, and we have it in 8x Haslog format. We have the 550, which can do 1.4 gigabits per second channel bonding and DCS, and 670, which can do 450 Mbps HCMP and DSO. I'm kind of not spending much time in comparison because we have the next slide. So this slide, you can download it from either take a screenshot or download it from our website as well. So this gives you a big picture of where the entire portfolio of Cambium with specs in detail. So on the left, you have Post 200 bridge in a box. So the applications for this is DIY sort of projects, short distance, maybe 1 mile or lesser than that. Post 300-25, this is used for high throughput. You can get about 600 Mbps. Short distance, typically 2 to 5 miles, depending on that. Then you have the 450i, which has narrow channel sizes, and it syncs up with the 450M, the 450 PMP 450 platform. Then you have the 550, which is the dual carrier, and you have the 670, which is the industrial grade or the top tier of the sub-6 portfolio. So the reason I kind of show all of these products is to give you the to talk more about the arsenal Cambium has. So it's not that we have just one product; we have many products, and each one fits a different need, a different market when comparing when fitting for a particular solution. So, for example, if you want a really if you're in a really tough environment where you are, but you require a high throughput, maybe you would want to go for a 550. Say you want to have capability of HCMP, which means you can use it as point-to-point or point-to-multipoint. You want to go with a 670, right? So having the diverse portfolio that we have gives you the advantage of using different tools and in different circumstances, right? So coming back to the 550, so why PTP 550? First, the 550 operates in 5.1 to 5.9 band. The headline throughput is 1.4 gigabit headline rate. It has 2 radios. Each can be configured as 20, 40, 80 up to 256 QAM. We will talk about this one in the next few slides. We have the asymmetric non-contiguous channel aggregation. It also supports, it already supports the fixed mode uplink downlink ratios. We have a few 50-50, 75-25, and 30-70. Latency is about 2 to 6 milliseconds. It has a live spectrum analyzer, which we will go over this thing. We have a dynamic channel selection. It's a roadmap feature, which we will talk about when we get to the roadmap slides. It already has a fiber port, so you can plug in. So you can plug in Ethernet as well as fiber to give your 1 gig capacity, as well as metal enclosure for IP 66, 67. SFP actually is a really important feature which we feel, because a lot of new buildings and constructions and towers already come with fiber connectivity. So all you have to do is connect through the fiber port. So it eliminates a lot of the interference caused by lightning as well as electrostatic induction in the Ethernet cable as well. So 550 comes in 2 flavors. One is the connectorized version in the 2 pictures on the right, and the integrated version, the picture on the left. It always comes in a kit. So the kit contains 1 radio, could be connectorized or integrated, 1 AC power supply. It's a 30 watt, 56 volt, this PoE. And it has a mounting bracket, which is shown in the connectorized picture, and it comes with a line code depending on, or it doesn't come depending on the SKU and the country code or where it's ordered in. This is the antenna pattern for the 550. It has a gain of 23 dBi. The beam width is 8 degrees, and the antenna dimension is 12 inches by 12 inches. So it's kind of small, compact, and it is meant for a really point-to-point distance with a good antenna beam without compromising too much. So if you have a really narrow antenna beam, it's really tough to align. But if you have a beamwidth of 8 degrees, it gives you good enough flexibility to move the radio around slightly to get the best performance. Next, I want to spend a few minutes talking about the FCC regulations and what bands are allowed and not allowed. Just to give you a quick perspective for some people who are not familiar with the FCC regulations. So you have 4 main bands that you use from 5.1, 5.2, 5.4, 5.8. There is 4.9, that's public safety. So that's useful for specific applications, but not useful for the general public. The 5.1 band starts from 5.150 to 5.250. The 5.2 band is 5.250, 5.350. The 5.4 band is this has the DFS radar detection part of it, 5.470 to 5.725, and the 5.8 band is 5.725 to 5.850. So the purpose of this slide is to kind of demonstrate there's 4 big chunks, and the 550 has 2 80 megahertz channels. So you can choose one radio in 5.1 band, which covers your 80 megahertz, and then you can choose the other radio in 5.8 band, which covers another 80 megahertz. It's kind of showing how we're working in chunks for each of these bands. Next, we're going to focus in on the channel aggregation part of it. So just the easier way to understand is the 550 radio has 2 radios built into it, right? So each radio operates with the counterpart on, let's say, channel A and channel B. And each channel can be configured as 20 megahertz, 40 megahertz, or 80 megahertz. So that gives us 6 combinations as shown on the slide over here. So if you're only able to get 20 megahertz channel size, you're sure that it's a really high interference environment where you're not going to get more than 20 megahertz. So it's a really tough environment to place the link. So you can choose a 20 and a 20. If you have a 2040, it depends. You're getting one cleaner channel. Similarly, you have 8080. If you're middle of nowhere, there's no interference from other sources far away. You can use 80 plus 80 and try to get full capacity of the radio. So this kind of flexibility has a lot of strength and a lot of merit in the long run. I'll give you an example. So one use case is reliable versus aggressive, right? So let's say you have 2 channels. One channel A is on 20 megahertz and 5.1. 5.1 typically has a lower EIRP, so you have less interference. 5.8 has a higher EIRP, so more people use the 5.8 band, so it generally has more interference compared to 5.1. It depends, but for this example, let's consider that. So if you have a reliable 20 megahertz, which let's say gives you 150 meg guaranteed on channel A, you can be a little bit more aggressive on channel B, because sometimes you're working at MCS 7, sometimes you drop back to MCS 3, sometimes your MCS rate or your higher modulation rate can change. It doesn't really affect your overall throughput because you already have a guaranteed 20 megahertz on channel A. So the channel B is just trying to optimize and be a little bit more aggressive and try to capture more of the spectrum whenever it can. If you have a single radio, it's tough to do because then you're focused only on stability of the channel. Because you have 2 radios over here, you can have one solid stable link and the other one can be a little bit aggressive and try to capture more bandwidth than necessary. The next one is the next use case is the DFS non-DFS band. This applies to many places where you have radar detection, military, or other sorts. Basically, what DFS means is you're scanning for a radar signal, and once you receive the radar signal, by law, you're supposed to take the radio down for at least 30 minutes. And after 30 minutes, you're supposed to come back up and check if the signal is gone or not. So if you have a single radio, it's really hard to use it on a DFS channel because you don't know when you're going to get hit with radar, and which means even if you get hit with radar, which means your entire network goes down for 30 minutes, at least 30 minutes. Right. But having the 550 gives you a really big advantage because you can choose one DFS band and one non-DFS band. Right. The advantage of the DFS band and non-DFS band is even if your DFS band, which is clean all the time, gets hit with interference, it doesn't pull down your link, or the link never goes down because all the traffic gets rerouted to the non-DFS network. And once after 30 minutes, when the network comes back up, it comes back to your DFS band, or if it moves with the DCS feature or roadmap, it moves to another channel. It comes back up over there. Having this reliability of two radios on two different channels makes a lot of sense, we think, and it improves the redundancy in the network, especially with a lot of interference coming along the way. Now, I want to spend maybe a minute or so kind of focusing on what channel bonding is, how it works, and what we see in the field and all that. We have a big community post link I've linked in the slide over here, which you can go through in really technical detail. The idea is channel bonding between the two radios. When a packet comes in, which radio do you send it on, radio 1 or radio 2? This calculation is based on something called a stream. A stream is a unique combination of TCP, UDP, source port, and destination addresses. So if a packet comes in which is for, let's say, IP address 10.10.10.10, which has it's a UDP packet which is source and destination, so it's a unique packet over there. Any other packet coming along the same source and destination is going to choose the same path. So if you have just one stream of the same data type coming in, it's always going to go on one radio, and the other radio is not going to be used. So you need to have more streams in the system to kind of balance or load balance out the radios. That's how it works. So an example is over here is when you have the 20 plus 20, you're getting 320 Mbps, but you need at least 8 streams to demonstrate that part of it. Example. Let's say you're 40 plus 40, you need at least 8 streams. So the more combinations you have, you at least need to have more streams. Now your question might be like, hey, how do I know how many streams there are in the real world? Right. In the real backhaul, you're going to have hundreds of thousands of streams. I'll give you an example. Let's say you're connecting 100 homes on your backhaul, and each home has probably 4 or 5 devices connected to it. So that's about 500 devices backhauling through your backhaul 550. Each device, so that's over there itself, that's 500 streams because there are 500 devices or unique devices. In that, actually, each cell phone or each laptop probably has 2 or 3 sessions. So you might have Skype running, or you might have your Outlook. So each one of them is a different stream. So you actually might have 500 times 5, so 2,500 streams. So the number of streams in the real world is different from the way you to test it in the lab. So if you test in the lab with the 550, you're going to get different performances versus where you run it in the field. So for that, we just did a quick experiment with MikroTik. So we just chose a 40 plus 40. We ran 4 streams. You can do this, by the way, in the lab as well. Ran 4 streams. For uplink and downlink, we get 542. We didn't change anything. All we did is change the number of streams from 4 to 10. Just by changing the streams from 4 to 10, 40 plus 40, we are able to get 579 Mbps. And if we make it to 300 streams on 40 plus 40, we're getting 629. So what this means is the channel bonding really works when there are more streams to play with, right? So the streams gives you almost like a flexibility or a flexible mode in which it can operate. So if you have just 2 streams, it's almost forced to choose one. Radio 1 goes on one stream and radio 2 goes on one stream. But if you have 300, you can kind of manage it, mix it around, and try to optimize every single time that you can. Right. So the post over here talks about in much greater detail. This is just a quick overview of how channel bonding works. Right. I also get a lot of questions on, hey, what should I choose, a 670 or should I choose a 550? How should I make that decision? What parameters should I need to consider? So this chart kind of gives you a quick overview or a quick high-level difference between the 550 and 670. The frequency band supported for 670 is from 4.9, which includes the public safety, to 6 gigahertz. The 550 from 5.1 to 5.9. Throughput-wise, 550 does 1.4 gigabits. 670 does 450 Mbps. But if you see the spectral efficiency, the 670 is much more spectrally efficient than the 550. So if you have narrow channel or it's a tough environment, you're only going to get 5, 10, or 20 megahertz. But you know it's a really tough environment. I would focus on the 670. Whereas if you have a clean channel, you want to have high throughput, short distance, I would focus on the 550. Even packets per second processing, that makes a lot of difference. So the 670 is built for like 800,000 plus packets per second, and the 550 is 100,000 plus packets per second. Even variability wise, 550 cannot do point to multi-point mode. The 670 can be used in HCMP mode and all that. Channel switching, both 550 and 670 offers channel switching. Each one has its own slightly different way of doing it, but in general, they do switch channel in terms of interference. The 550 will have the DCS, the dynamic channel selection, which is the channel switching feature. It's in the roadmap, which we'll talk about in the next few slides. But yeah, it will have that feature. Encryption-wise, 670 supports a lot more features, AES 128, 256, OTAR, whereas 550 just supports AES 128. So 670 is more secure, robust. 670 also supports SYNC-key, 1588 timer, network timing protocols, and all that stuff. 550 doesn't focus in on that mainly. So the main idea, the key takeaway that you can sense from all this is 550 is built for short distance, high throughput channel mitigation or channel switching if there's interference. 670 is for like really high PPS, narrow channel sizes, high spectral efficiency where you want high reliability, where you want DSO and jumbo frames, or special applications where you need jumbo frames, 1588 timer, SYNC-key, etc. So it's almost like a specialized model for 670, whereas 550 is kind of like a simple short distance, high throughput kind of a radio with comparatively less feature sets. I think this makes it clear on a general level on when to focus on 550, when to focus on 670 as well. There are a lot more things to talk about, like 670 has the aux port, split frequency. That kind of gets into a lot deeper discussion, which is probably not for now. But I think this gives you an overall generic idea. Next, now let's come focus on the roadmaps and feature sets. So this is the roadmap for, I should have written 2019. So you can see on the left, we released the 412, which had the wireless link test, link optimization, HCDFS 5.4. 4.1.3 came out in October, which had small packet optimization, jumbo frames, latency, load balancer, TCP optimization. So 550 was launched at March, so less than a year ago. So a lot of features are coming in from June to January. In 4.1.4, we had a lot of latency improvements and stability and bug fix. Latest release in the 4.3, we had Cambium Sync, VLAN features, latency improvements, and all that. So what is coming up next? What is the next firmware? So the next firmware is going to be probably towards the end of the quarter, and we're working on two big chunks. We will also have small incremental changes, but as we get closer to it, we will keep adding it. But the two main boulders that we are currently working on is QoS, which is going to be of 3 levels, and a DCS feature, which is the key feature for the 550. So the DCS feature mainly says, okay, so we're going to have how should the radio perform under interference, right? So let's say you're on a 5.1 band and a 5.8 band. Let's say your 5.8 radio gets hit with interference, and now it has to move. So the channel selection, do you want to choose the same size elsewhere? Do you want to choose a narrower channel size? So all these feature sets come into play. We are working on it. Once we are close to releasing it, we will have a webinar explaining in really great detail about how channel selection works, what parameters we are going to consider, and when it moves. Two other firmwares we are waiting for. The first one is the FCC IC DFS, which is the 5.4 band allocation. We have already applied for it. We are just waiting for the government to open and then approve it. So once that happens, we will have, as soon as we have the approval part of it, the software and everything else is ready. We're just waiting for the government to approve. And then as soon as we have it, we should have a firmware out within a week or so once we have the grant part of it. The second part of another FCC certification that we're doing is so initially when the 550 came out, we certified with 3 dBm TX power, which means it limited the antenna gain that you can use. Now with 4.1.4, you can actually go down to -9 dBm. So we are recertifying with the FCC with a low power, which means ideally you can have at least 12 dBm of higher antenna gain. So before, if you were limited by 2022 or 30, you can have it at, if it's 22, you can have it at 34 dBm. You can have a 34 dBi antenna gain dish. So we are working on these two certifications. We will keep you in the loop as to when we have it, or when, as soon as we have it, we will have a firm release to share it with the public. So this kind of gives you a roadmap feature set. We have a lot more things going on, but we don't want to. We only want to commit what we have committed. We are going to write it, and as we get closer to the end of quarter, we will have probably another webinar in which we will go over the feature sets and or the release firmware in much more detail. There are a lot of tiny quirks that we're working on that shows over here. I give you an example of one of the tiny quirks. On the second column, 1, 2, 3, 4, fifth one, we have the scheduler guard interval support. So this is a really simple feature set that we have added in 4.1.4.3. So what this does is, if you're sending 550 over water, you want to have the guard interval slightly longer because you want to wait for the reflections to come along. So these kind of small features are going to be included in the next releases, but it's hard to predict when or where you're going to have it. But once we get closer to it, we will start filling it. So with the 4.3.1, these are the features that we support, or these are the applications that we have. We have ARQ support, channel bonding is supported, improved spectrum analyzer, which we'll focus in the next couple of slides. We have the FCC 5158, HC bands, MCS rate fully adapt, which means what MCS rate full adapt means is, let's say a packet is at MCS 7 or modulation of 7, then suddenly the interference or the network conditions goes bad. It won't go to MCS 6 and then MCS 5 and MCS 4. It directly jumps to MCS 3 and then comes back up. So it's almost dynamic, which means you're adapting almost instantaneously to the network environment. We also have E-Align to help with alignment. ATPC, automatic transmit power control. So if you set your RSSI on the slave, the TX power is automatically adjusted to reach that RSSI level. We also have small feature sets like trace support, pings, radius authentication, CMM5 pulse support. So you have Cambium Sync as part of it. We already talked about the scheduler guard interval program. We already have CN Mastro, VLAN, data VLAN, 1700 packet size, and Watchdog. So this is an exhaustive list of all the feature sets that is already there with the 4.3 release part of it. So I want to spend maybe a minute focusing on the online spectrum analyzer. So in the new 4.3 version, we have two modes of spectrum analyzer. One is called the light and the detailed, highlighted at the top, scanning one. So if you choose light, it gives you within a few 5, 6, 7, 10 seconds, it gives you a quick overview of the spectrum that you're seeing. Whereas if you go detail, it's going to spend a few minutes and give you the exact detail with much more accuracy than the light version. Another one we have added is the interference detection. It detects other Wi-Fi devices or other products in your spectrum scan. So, for example, in my in the screenshot over here, I have interference detected with RSSI level next 75 and in the frequency 5180, and this happens to be my cell phone, which was near 550 link. And we were able to detect the SSID as the OnePlus, the vendor being OnePlus, and it also gave me what RSSI, what frequency I'm using, what channel size that I'm using, what mode, am I a master or slave, how many packets. So it gives you a quick exhaustive list of other interferences that you have. The other advantage of this is you can use this RSSI value to calculate your current SNR. So before you had to calculate your RSSI, what you were getting, and then you have to look through the maps to figure out what your RSSI would be. Now you can just subtract, let's say your E-Align number shows NEC 50, right? And you have NEC 75 over here. So you know your SNR is somewhere around 25 in this thing. Next, we also have GPS sync or Cambium sync. So this comes with our CN Pulse device that we have. So when you use a CN Pulse, you just plug in the input and then the output goes from the aux port to the radio. The highlighted circle over there, as soon as you see the location become green, it means the pulse is being received by the radio. We don't showcase it over here, but we are receiving the GPS sync pulse. To get more information on the data on the serial GPS information, you would have to use the CMM5 because that sends the GPS data. The CN pulse does not send. But if you want to use the data, you can always log into the CN pulse serial port to get more information from that part of it. We already support CN Mastro for 550. A lot of people on the call already use CN Mastro. It's really, especially for EPMP and 450 platform, just adding in the 550 gives you an overall view of how your network topology works. So advantage of CN Mastro, as you all know, is unified way of network management, hierarchical device, so you know which packet goes, or which AP goes to which SM goes to which backhaul. You also have alarms built in, so critical, minor, this thing, and also you have reports and all that stuff. Now I want to spend maybe a few minutes talking about case studies and reference materials. Some customers say like, hey, where can I study more about it? Where do you have a reference material on it or something along those lines? I say, okay. So the first case study that we have is in rural Argentina. This is for the 550 link. I chose this particular case because to show the distance component of the 550. So in this case, it's a 49-kilometer link. The top right corner gives you the link planner profile that they had used. It's a 49-kilometer link, and they're using 220 megahertz channel because they want to try to get more throughput. It was a tough terrain overall. It's a rural area, so a lot of vegetation. So they were able to get 217 Mbps in a 40 meg channel, which is pretty good. So they used 231 dBi dishes. So we have the case study online. You can click the link, or you can just Google the title, and you should be able to find it over there. So this gives you a quick idea of like, hey, 550 works not only for short distances. If I want to use long distances, in case I have interference on one radio, the other radio takes care of it. Having that balance or redundancy, I think, makes sense, especially if you're taking this for a longer distance as well. It has not only applications in short as well as the long one. The second one, customer deployment, is from the Croatia. So this is a 5-kilometer or 3-mile link. They use 240 megahertz, TDD 7525. They use 29 dBi dishes, and they were able to get 650 Mbps in the 80 megahertz channel size, so 240 over there. So this also gives you a quick sample of like how customers are using it. So they're not only using it for long distance, they're also using it for short hops. Relatively clean channels, you can get really high throughput capacity on this one. So learning on 550, we have a lot of material. If you go to YouTube, we have PTP 550 installation and configuration. This gives you a quick overview of how to set up the radio, what comes in a box, where do you click buttons, how do you configure each channel, what country to choose, what MCS rate, what TX power. We talk about everything. It's a 20-minute video. We try to cover as much as we can in this one. Next, we have the PTP 550 best practices. This is, I think, another 10 to 15-minute video. This talks about what things you need to focus on when working with 550, especially configuration-wise or testing it in the real world and all that stuff. Third video we have is how to configure multiple streams on JDSU, especially if you're testing 550. This makes a lot of sense because going back to the channel bonding, where you have to use multiple streams. So if you use a single stream to test on JDSU, you're only going to use one radio, so you're not going to fully utilize the potential of the 550. So by using the video, you can kind of understand how to play with JDSUs to set up 4, 5, 8 streams, as shown in the pic diagram in the channel bonding slide. You can set up those X number of streams, and based on that, you can test using even JDSUs. We also have PTP 550 link using MikroTik, the same thing as the JDSU version, but we have it for MikroTik. It's a 4-part series. We talk in really great detail about how to configure and set up each part of it to check or to configure it on MikroTik. We also have a few demonstrations as part of the videos. So I'm pretty sure if you go through all of these videos, it gives you a really good idea about how 550 is, how it works. It gives you a background as well into. So if you have never touched a 550, just going through these videos, it's not that long. On average, each video is around 10 to 15 minutes. So if you spend about an hour covering all these videos, you should have a really good idea about how to set up 550s and test out and play with your own play with the stuff in your lab. We also have blogs. So we have channel bonding load balancer, as well as testing, how to test in a block format, which tells you step by step in a PDF version or a blog version how to do it. We also have a lot of questions answered by people. Please post any questions you have on community.cambiumnetworks.com, or you can go to the forums and press your questions. There's a lot of people who've already asked interesting questions on, like, hey, how can I have a 15-kilometer link using this is my spectrum? How can I help me choose my best channel, and help me choose what MCS rate I need to pick and what TX power I need to keep. So we answer all of these questions on our community forum as well. So this gives you quick learning material to catch up on all the 550s and some quirks and features. So just stepping back and wrapping up, what is the key differentiating feature for the 550? So the 550 is a solution focused for customers who opt for 1 gig plus backhaul solution, which also handles interference as part of it. So it does 1.4 gigabits headline data rate. It has asymmetric non-contiguous channel aggregation. So we talked about the DFS, non-DFS use case. We have the resilient and aggressive network. The 552 radios are asymmetric modulation. What this means is, if you have radio 1 on MCS 9 and if you have radio 2 on MCS 3, it automatically works independent to each other. So both radios don't have to be at a fixed modulation rate, because we know in the real world things are different. So you cannot expect both the radios to work at the same MCS. So having this asymmetry or making them work independently makes all the difference. Link resiliency. This is one of the key feature sets for the DCS. So the dynamic channel selection feature that's going to come out by end of Q1 is going to focus on how or which way can we reduce link or improve link resiliency, especially when either one link goes down or there's a lot of interference on one channel just out of the blue. So the link could go down either through DFS detection or any other random interference that comes in, or there's a session drop for whatever reason. So automatically, how does it handle that resilient network? The 550 also has ARQ. So this is the ARQ protocol is really useful to send packets across the 550. The 550 is also compact and durable. It has a metal foam IP67, so it's resistant to heat, weather. It's a long-lasting product. It's going to survive a long time, and it also has a fiber port built in, so you can either use the Ethernet port or the fiber port, which are described over here. With that, thank you. Please write in your questions, and I will take them one by one. Also, all the decks and slides will be available online on our community page. So Joshua has a question: how MPLS traffic is handled? So 550 is a layer 2 traffic. So as long as it has a packet, it's a TCP or UDP packet is a stream. So it's considered as one stream and it goes through that. So MPLS, it's a different way of doing it, but because inside the MPLS you'll have different streams, so it picks on that and then transmits the data. Thanks, Mark. Hey, Melissa from Atlanta. Are there any more questions? Maybe I'll give another 30 seconds if anybody has a question. So Mark has a question: anything planned after DCS? Yes, but now we want to work out those feature sets and then kind of comment on it. So we have a few things planned in the future for the 550 platform as well. So our main focus right now is QoS and getting DCS right. And then there's always tiny updates that you can do, which shows up as with every firmware feature. But for the next 3 to 6 months, our main focus is on QoS and DCS. Once we kind of get past or get close to that, we will we will share our next roadmap features or roadmap updates as well. Okay, those were the questions. Thanks everyone. Thank you for the call. Please visit cambiumnetworks.com community page for the slides as well as the YouTube video as well. Thank you. Bye.